So in this video, we're going to talk about Ethereum and how they do their own consensus, how Ethereum works. So let me quickly. So Ethereum, we said Ethereum works with proof of stake instead of proof of work. So now there's something else. We are familiarized with the concept of blocks building and stuff. So in Ethereum, every 12 seconds, a block is added to the blockchain. So each 12 seconds is called a slot. So when you get the word slot in Ethereum, we're talking about 12 seconds. So for every slot, there is a block. For every slot, there is a block added to the blockchain. For every 32 slots, we call it an epoch. So epoch is the time, I think about 6 point something minutes. If you calculate 12 seconds times 32, it's an epoch. So when you get the word epoch, it means 32 slots, 32 12 seconds. So for every epoch, there are 32 blocks. You know what we said? For one slot, there is one block. So in Ethereum, for every 6 minutes, there's a new block. That's how fast it works. Now, we're going to use this to explain how exactly they maintain the nodes across everything in Ethereum. Now in Ethereum, they make use of voting, unlike Bitcoin that they have to work, and the fastest person has to be the one to suggest the block. For Ethereum, it doesn't work that way. Let me explain. So for the epoch stuff, let's say these are the various epochs. This is every 6 minutes, 6 point something minutes. Then we have different. These are the slots. It's supposed to be 32, but they just assume it's 32. So this is called a slot, and this is called an epoch. This is where every 12 seconds the block is formed. I'm going to use this to explain now. For Ethereum, let's say we have different nodes. So we have 1, 2, 3, 4, 5, 6, and each of them has they have a block they are maintaining, a chain of blocks. Now let me just use my phone. And now there is you. I'm going to break down the step-by-step process of when you want to make a transaction to everything and how everything is maintained. There is you here. You want to send 5 ETC from blah 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 to blah blah blah, just like we know it. Now the first thing that's going to happen is this. This is your message. It's going to be broadcasted to not all, remember, because then we have a lot of nodes. The reason why we cannot use that PBFT method is because remember we said PBFT method works when we know the number of voters. For Ethereum, we don't know the number of voters because anybody can wake up and become a node. So they are uncountable nodes sometimes. Now, what happens is because of this uncertainty in their number, your transaction is not sent to every node. It is only sent to a few of them. So let me just draw a little demarcation to note the nodes that. Let's say these are the nodes that your transaction got sent to. And there's another person, let's say Mr. B. Let's say this is Mr. B. Sends 4 bits. Yeah, sorry, let me know the word BTC. Okay with ETH from 2. Now this person's maybe because of this person's location, it's just only this half. Only the people on this side that will receive his own transaction. The nodes that receive his own transaction. That is what I was trying to explain. You might have inconsistency sometimes. So because of this, remember we said there's something called the mempool. We explained all this stuff before. Each mempool will be different from every other mempool. So this is the let's say this is the mempool. This is everybody's mempool. So the contents of each of these mempool will be different for everybody. I should make this too. So these are the blockchains, and the pink ones are the mempool for easy understanding. So let me change this person to green. BTC. So, like we said, this person's BTC might be in this main pools, whereas this other person's one might just appear in this main pools here. So you can see that everybody's different. For this, you can see that this person's main pool is different from this person's main pool. It can also mean that there are other main pools that contain from another transaction. So that is how the distribution works. So no particular main pool, no two main pool are the same. Every main pool is different. So because of this, they have to maintain a certain kind of consistency, just like Facebook, because they do this by voting. So how do they vote? Now, if you initiate something like this, there's something called the proposal. I need to explain something. At each of this epoch, something happens. Two things happen. Number one, the system, the code, it has to bring up or nominate it makes two particular stuff. The first one is a proposal, and the second one is a committee. 32 committees. Now, this proposal, he has to nominate, he has to bring out 32 proposals. Now, what's this 32 proposals does is for each of, remember we said in one epoch, so we are this epoch now. In one epoch, or at the end of this is the start of the epoch. In each epoch there are 32 slots. So this 32 proposal, 32 committee is for each of these individual slots. So for slot 1, there's one proposal and one committee. The committee, we don't know how many people are in the committee because of the fact that we don't know how many nodes there are. So for each of these slots, there is one proposal and a committee. So that's why we have this. So for this, at this point, this system, the code generates automatically. That's the proposal and that's the committees. And tells the people involved that okay, we are a proposal here, we are part of the committee. The proposal, the work of the proposal, I'm going to show you very soon. So these 32 of them will be assigned to different 32 slots so that at the end of this particular, when they get to this epoch, everybody have already done their work, and this epoch will produce the same stuff for the next. I don't know if you get what I'm saying. Now, the work of the proposal, first of all, is the time you made your the time you initiated your transaction, and you pass it to what's it called, to the nodes around you. Let's take for instance, you're white and you pass your transaction. Transaction is in. Anybody can be a proposer. Understand? For let's say you are lucky and at the time of you passing the transaction, this person is the proposer. Has been selected. Let's say you pass it around this person is the proposer handling this particular slot. So this proposer now will combine, will not be the one to combine the block, just like in BTC. You combine a block, just like the word. You combine a block, and then this is the block. They will compile the transaction they have in their main pool, and then this will now be the block that they will now broadcast to everybody. So every single node, you see this block that was proposed, every single node in this Ethereum system receives it. That's basically how it works. So that's the work of the proposer. So for every 12 seconds, there is always somebody that is broadcasting something. Now, if every single entity receives this stuff, everybody will be just like you sending the answers, or let's say there's a question x plus y equals to what? This person got 16, this proposer got. So this person is going to send this stuff to everybody. Everybody is not just going to add it. Everybody is going to solve it by themselves. They will keep the proposals on by one side, solve it by themselves, then they will compare the both of them. If the both of them are exactly the same, we'll add it to their block. It's as simple as that. That's how it works. Now, how do they now know? There's something they will now have in the committee. After the proposals have done this, you've sent out your proposal and people have added it to their blocks and stuff. The committee that was selected are the people that will now do that set of votes. The reason why we have a committee is because we have an infinite number of, not infinite, sorry, we have an unknown number of votes. So we have to have a select group of people to be able to do the voting that we talked about, So that committee now, let's say we have a committee of 4 people. So that committee will now write something they call an attestation. They will now do a voting, like they'll actually send votes among themselves. Okay, all of us we saw that we compared this stuff. Remember this stuff was just this activity we did, that they will solve theirs and they will compare with what was given to them. The people here will now write an attestation that okay, it matched. So maybe we can have 3 match and 1 mismatch. Maybe the person solved it wrong or something. Now this attestation will be added in the next proposal. So for every time they want to propose a block, the block contains both some details about transaction and also attestation. They always attach attestation. So in Ethereum, there's always an attestation in the block. You understand? So this attestation now, we're going a little bit too fast. So at the end, after they've done the voting and everything, if you sent your stuff, proposed it, everybody has checked, some have added, the committee will now do the stuff, write the attestation. Now this is for this first 12 seconds. That is gone. For the next 12 seconds now, a new proposal will arrive. Let's say this is the new proposal. So this new proposal now will still propose something, a list of block, a hash. Then they will now this new proposal will now add the attestation from the previous vote here. The reason why they're adding the attestation is so that everybody, after adding the attestation, let's say this is now the attestation here. And now they will now broadcast this attestation to every single person, to everybody. Now everybody can now see that okay, most people worked with this particular previous block. That's exactly why you have the attestation being added. So that's how the cycle repeats. It repeats. That's why every second, every 12 seconds, there's always a block. So this keeps repeating until you get to an epoch. So now, like I said, your stuff has been added. You get to an epoch. Then at the end of the epoch, or at the start of a new epoch, you will assign the same another set of 32 proposals, committee, and everything. So now there's something again they do at the end. Remember, we've talked about what happens here. Let's talk about what happens here. At this epoch, we will now obviously have have 32 blocks that we change to each other. It's not final. We have 32 blocks to change because we have 32 slots here. Now, these 32 blocks now will now undergo review. The review is now like everybody sees the last block and the attestation. Everybody sees every attestation. So if 2/3, remember from the PPFT method, if 2/3 of the entire population, like they're looking at the attestations, if 2/3 of everybody has the same chain of blocks, remember some can have different chains just like this too, based on different regions. So if 2/3 of everybody is on the same block, then this particular set of blocks that were compiled in the previous epoch, we will just put that, I've forgotten the word, I think justified, no, not justified yet. What's the word? Give me a minute, I wrote it down somewhere. Okay, the word is justified. It's justified. We call it justified, but not yet permanent. Not yet very, like, not yet 100%. They'll have to wait until the next epoch before it is 100% for whatever reason. I don't want to go deep into it, but there's a reason why. If it is not up to 2/3, then it is awaiting justification. Basically, nothing gets dropped. Maybe I might create a video later for more explanation on this, but just know that the PBT method goes at the end of an epoch. They will now check it. If it is up to 2/3, it is justified. If it is not up to 2/3, it is awaiting justification. And the reason why is because sometimes not everybody gets to. Sometimes some nodes are not online, so you can have 1/3. You can have it's not passing 2/3 test, but later it will not pass it because most people are not online. Maybe when they not come online, things not align well. Then it's work out. So that is how basically Ethereum proof of stake works. Now the name proof of stake. Proof of stake. Remember in BTC, the consequence of lying is that the money you wasted to solve that mass equation, the money you wasted to solve the equation to be the first person to propose will be gone. In Ethereum, you have to, before you become a node, you have to stake Ethereum, I think 32 ETH, something like that. You have to stake it, you have to put it in, and for every time you mess up or you propose a false block or you do something malicious, they will reduce money from your balance. They will reduce money from your actual money you put there. You understand? This also has a reason. This also has all this stuff I just explained has something. Also has a hand in why Ethereum gas fee is high, because they are processing a lot of transactions so fast. So each of these proposers, which want to propose a block, they look at the transaction that has higher gas fee, and that's how it will keep rising and rising and rising. All these things, that's how it works. I'm not 100% on them, but this is what I understand so far.